Imagine a time before time itself, a place of cosmic chaos. Before us, before the mountains and the seas, before even the ground beneath our feet, there was only a swirling disk of gas and dust spinning around a newborn star. This is where our story begins, 4.6 billion years ago, in the violent and magnificent birth of our solar system. From this primordial cloud, gravity, the silent architect of the cosmos, began its work. Dust grains clumped together, growing into pebbles, then rocks, then planetesimals, the building blocks of worlds. Among them, one was destined for a special future. This was the Proto-Earth, a growing sphere of rock and metal, enduring a relentless barrage of collisions in the cosmic demolition derby of the early solar system. Around 4.54 billion years ago, a pivotal moment arrived. The accumulated heat from these impacts and the decay of radioactive elements turned our young world into a molten ball of fire. In this planetary crucible, a grand separation occurred, a process called differentiation. Heavier elements, like iron and nickel, sank towards the center, forming Earth's dense core. Lighter materials, the silicates, rose to the surface, creating a vast, roiling ocean of magma. This fundamental structure, established in the fiery dawn of our planet, would one day power the magnetic field that protects us and drive the very tectonics that shape our world. But Earth was not alone. In a cataclysmic encounter that would define our planet's destiny, a Mars-sized protoplanet, which we now call Theia, delivered a glancing blow. The impact was titanic, unimaginable. A colossal spray of vaporized rock from both bodies was blasted into orbit. Over time, gravity once again worked its magic, pulling this debris together. A ring formed, then a sphere, and our companion in the sky was born. This is how, 4.5 billion years ago, we got our moon. This giant impact didn't just create a satellite. It tilted Earth on its axis, giving us the seasons, and its gravitational pull would stabilize our planet's rotation and create the tides for billions of years to come. The Herdean Eon, named after the hellish underworld of Greek myth, was just beginning. For the next several hundred million years, from about 4.1 to 3.8 billion years ago, the inner solar system endured a final, brutal assault known as the Late Heavy Bombardment. Comets and asteroids, leftovers from planet formation, rained down upon the terrestrial worlds. The surface of the young Earth was a scarred, violent landscape, constantly reshaped by impacts that could vaporize entire oceans. The Moon still bears the craters from this era as a timeless testament to this chaotic period. Yet, amidst this inferno, a transformation was underway. As the bombardment subsided and the planet continued to cool, something miraculous happened. Steam that had been locked within the planetous rocks or delivered by icy comets poured into the atmosphere. It condensed, and for millions of years, it rained. A global deluge filled the vast basins, and by about 4 billion years ago, the first oceans were born. A primitive crust, perhaps more like the dark, heavy basalt of today's ocean floors, began to solidify, forming volcanic islands in a world-spanning sea. The stage was set. The Earth was no longer just a ball of fire. It was a water world, poised for the next great chapter. As the Herdean Eon gave way to the Archean, a new dawn broke upon the Earth. The planet was still alien, the sky a hazy orange, the sun dimmer, the oceans rich in iron, giving them an olive-green hue. It was in these ancient waters, around 3.8 billion years ago, that the greatest mystery of all unfolded, the emergence of life. We may never know the exact moment or the precise mechanism, but from a complex soup of organic molecules, the first simple cells, prokaryotes, arose. Life had gained its first, tenacious foothold. It was a quiet revolution, invisible to the naked eye, but it would ultimately conquer the planet. At the same time, the very ground beneath the oceans was changing. The planet's internal heat engine was churning. Plumes of hot mantle pushed up from below, creating the first small landmasses, protocontinents. These were not the sprawling continents we know today, but likely small, unstable volcanic islands dotting the global ocean. They were the seeds from which all future lands would grow, tiny outposts of rock in an endless sea. Then, around 3.5 billion years ago, a new biological innovation appeared that would change the world forever. Some of those early life forms, known as cyanobacteria, developed a revolutionary new process, photosynthesis. They learned to harness the power of sunlight, using it to convert water and carbon dioxide into energy. And in doing so, they released a waste product, a gas that was toxic to most life at the time, oxygen. At first, this oxygen didn't build up in the atmosphere. Instead, it reacted with the dissolved iron in the oceans, causing it to rust and precipitate out, sinking to the seafloor. Over hundreds of millions of years, This process laid down vast deposits of iron ore, creating the banded iron formations that are now the primary source of our steel. These red-banded rocks are a silent, global record of life beginning to terraform its own planet. As we move toward 3 billion years ago, the geological engine of Earth continued its work. The small proto-continents, driven by the forces of plate tectonics, began to collide and merge. They grew larger and more stable, forming the first cratons, the ancient, durable cores of the continents that exist to this day. These cratons, like Ur, Vulbra, and Kenneland, were the first true supercontinents, vast expanses of land in a world previously dominated by water. The Archean Eon, a time of firsts, first life, first continents, first breath of oxygen, drew to a close around 2.5 billion years ago. The planet it left behind was fundamentally different from the one it had inherited. The relentless bombardment had ceased, the oceans were clearing of iron, and a new, potent gas was slowly, irrevocably beginning to accumulate in the atmosphere. Life had not only survived the harsh conditions of early Earth, it had begun to shape them, setting the stage for an oxygen-rich world and the explosion of complex life that was still billions of years in the future. From a disk of dust to a living, breathing world, the story of the Hadean and Archean eons is our story. It's a story of fire and water, of chaos and creation, of the incredible resilience of a planet and the tenacious beginnings of life. It is a reminder that we are standing on the shoulders of 4.5 billion years of cosmic and geologic history. Thanks for joining us on this journey through Earth's deep past. If you found this story as awe-inspiring as we do, be sure to like, subscribe, and hit the bell icon so you don't miss our next chapter in the epic story of our planet. See you next time.